sphere, use the science on the sphere 5 or 6 times a year. Sometimes you forget some of the nuances of the controls. And in my previous stoppage of the Earth rotation was an example of that. So what we have when you study sea ice, if you want to study sea ice, it's very easy to do if you have the right frequency of passive microwave radiation. And this is why certain frequencies of radiation are extremely important to Earth science, because you have very basic physical couplings between, in this case, the emission of electromagnetic radiation at those precise frequencies and where you have sea ice and where you don't. So you're able to use data from passive microwave radiometers to study sea ice if you're working at these frequencies. And because these instruments are passive and we're dealing with fairly long wavelength radiation, cloud cover doesn't matter and you don't need sunlight. That's very important to study, in this case, sea ice in the far north or far south during their respective winters when there's no sunlight. So what you're seeing, and the time is here, the time scale is also displayed on the image as the Earth rotates. What you're seeing then are these variations by month, actually every few days by every few days, of sea ice in the Arctic and sea ice in the Antarctic. Now, because you're using polar orbiting meteorological satellite data, or polar orbiting satellite data, you're able to go to the poles on every orbit. So this type of orbit is really crucial for studying the poles because you get 14 looks a day. And what we find is that sea ice, over time, is decreasing at a fairly alarming rate in the Arctic. And not only that, but it's decreasing at a much faster rate than our numerical models can predict. This is one of the uses of satellite data, is to, when you have numerical models of climate, or sea ice in this case, you can look at those data and you can see if things agree, and if they don't, then you don't have the physics, or you don't have the initial conditions correct. You need to figure out what's wrong to improve your model.